Okay, I'm John Simon. I have posted on the in-call messages a link to the script that we will be reading from, or at least guiding our speech. And there are photos on there, so you might, if you can, look at it on another screen, or indeed look later to see what we've been talking about. There's two aspects here. One is what we've done to the UKMARS robot, and the other is what we plan to do at the school. Now, I'd be guided by how much you want to talk about each of those things, but the script has got basically what we're doing at the school first, and then I go on to talk about the hardware and the software, and what I think is interesting things we've done that you might be interested in. Can I get a quick show of hands as to whether you're interested in what we're doing at the school or what we've done to the robot?
Both.
That looks like a vote for a school to me. Is that right?
Huh? It's a vote for both.
Both. Okay. Well, I'll carry on according to the script then. I can put the script, if I try hard, show a tab, and the tab I'm showing is our script. So bye-bye from us, and you'll get the script instead, but you should keep getting the sound. Have you got the sound?
Yeah.
You have, right. Debenham High School. This is not a real official website. It's something I cobbled together just so that I could publish the script I want to show you. And this is our robot number 5, and you can have a look at it and see that it's got about 6 changes there, or 6 significant things. Firstly, can you see the arrow?
Yes.
Yep. You can, right. Well, we've got a Pico on top with quite a sizable piece of Vera board, which makes it a bit easier connecting. And it's more or less above the Arduino socket. We have shifted the analog switch mechanism to become 4 digital inputs, which make a lot more sense because the Pico has got a lot more digital inputs and far fewer analog inputs than the Arduino. It's also got a hole through which is pointing a blue pen, which goes all the way down to the bottom through the bottom circuit board where the encoders would have been, but aren't. We have got 1 or 2 of the robots which actually have encoders, so they won't be used for drawing. What have we got on here? We've got the serial lead has got 4-pin socket on it now, which is angled gently so that you can still get the USB in. And I had to swap some of the pins there to make the Bluetooth module work. But instead of the Bluetooth module, we have got a TV remote, which is possibly easier to use at a school where you don't want people getting their phones out. But it does mean that one remote will speak to every single robot. So we need some black screens around the room, or we need some cooperation between the students. The use for that will be described later on. Coming further down the diagram, we're running the line sensor of 3.3 volts with some slight change to the resistors on the LEDs to make a bit more light at the lower voltage. And we are not using the enable-disable transistor. We've got the link permanently in, and we're hoping we don't get problems with ambient light changes. Okay, that's a rough description of the robot. About us, we've been doing robots since 2000 and whenever. 2006, I don't know, looking or earlier than that, perhaps.
Earlier, I think, yeah.
And we were using pickaxe, we were using very slow motors. So all the drawing was very appropriate because all the angles were absolutely accurate. And there was plenty of place to put the pen in. So that's one of the reasons why we've brought that forward. But a significant fact about this whole project is that we haven't had a proper talk with the teachers, what they want the students to learn. So it's going to be a big exercise of discovery to see what they want to get out of it. But I'm describing what we expect to be able to, but it might not actually happen. So we'll be getting the students to program. Ideally, they will program it, full stop. To get them to that stage, Python is very good because of the command line REPL, and we will put together worksheets when we know what the teachers want, to take them through the REPL technique for writing various lines of code and then putting it together into a file and then running it. But Python and the Pico are very good for finding out what's wrong with your program before you download it, which is something with a pickaxe. We would get problems. They changed something and nothing worked at all. So hopefully it's going to be a better learning experience for them. And we'll do the usual things: inputs, analog and digital, outputs, on or off, driving LEDs, or PWM driving the motors, or indeed PWM driving the LEDs. Decision making. Python, if you've come from a basic background, has got some really strange constructs. For loops seems to have disappeared and are very different. So we're having to learn quite a lot there. But again, we'll be guided by the teacher, just what we want, basically what we want to teach them. But we want them to end up learning that programming robots is fun. You can make them do all sorts of interesting things, and you can win competitions. Programming is about being organized, and using constants, functions, and objects, and import files and so on is very important for helping other people understand the program. And indeed, that other person can be yourself in a few years' time looking back at old code. So we'll be flashing lights, drawing patterns with the pen, line following, and drag racing. We won't be maze solving. I think this is a step too far for the level of students we're doing, year 7 to
There'll be year 8s.
Sorry, year 8s. And it'd be too much of a big chunk of program they don't understand that would be solving it. Okay. This next section on the script is actually what I've talked about already. Do you want to say anything about the electronics, Simon? You have got some hardware ready, haven't you?
Yes, we have a board with a Pico on, a battery regulator, some LEDs to turn on and off, and a switch as an input. We're going to use that board so the pupils can prototype circuits as they learn them. But the only thing we know is the club is going to run on a Wednesday. We don't know how many pupils are going to be there, what their abilities are. We don't know whether Funny will work with the pupils logging. We have got to behave like a normal teacher would and just be prepared for the first bit of a lesson. Hopefully we'll know what to do for the next lesson.
Will you be getting the kids to do the soldering on the UKMARSBOTs?
We had thought of that. It depends how good they are. If they can solder, they could solder the the sensor boards, which are quite straightforward. But I don't think I would like them to solder the piggyback adapter in case they got anything wrong, which would end up destroying the Pico when we plugged it in.
Yeah, you'd probably have to make a proper PCB for the adapter.
We don't know how to do that.
Okay.
Okay.
Can I just, in terms of how the MarsBot is adapted, you've basically got something which is getting the pinouts off the motherboard of the UKMARSBot and remapping those around to match up with the Pico.
Yes.
And you've also got another board sandwiched in there, I think, which gives you power regulation and your switches. Is that an accurate description of what the robot looks like?
I just put you up a picture of, well, let's have a look at the tab. That is a side view of the robot. So the top there is the Pico.
Yeah.
The middle is an adapter board very similar to David Hannafan's adapter board. We've simplified it as much as possible. On the bottom board, we have sneakily put the regulator on there. So that board there is the limit of where 9 volts goes to and 5 volts goes up onto this Pico board. We can put it in front of the camera if you like. I'll just see if I can do that. Let's have a look.
See that?
Can we see that?
Oops.
There's the camera.
Yeah. So you're passing those signals straight up through that regulator board and then up to the Pico board on top.
That's correct. There's one instance where we've got a 5 volts coming in, where we've actually got resistors. I'll take the Pico off. And you can see there's one resistor there, and one on the inside and one on the outside, and they are reducing the 5 volt button down to 3.3 volts.
Yeah.
But the 4 switches, where are they going? Let's have a look at them.
Yeah.
They are literally straight connected to 4 input pins. It's really straightforward there. So Veraboard works a treat. And it's not that complicated. There's not a lot of wires. It's something we could get students to do, but I don't think that's what the teachers expect them to do in the club.
I feel myself that the more actual construction that the kids do, the more they feel they own it.
I agree.
Okay.
Yeah, I'd agree with that as well. We actually had 10 students building UKMARSBOTs, and I soldered the complicated bits sort of underneath the Arduino Nano, but I let them solder the resistors by the 4 switches, and also the sensor board and some of the other connectors, put the LEDs in and things, and they were very, very keen to do that. We're about to start again with another group of up to 10 year 8s, but we've only got now 2 soldering irons, so I'm not quite sure how we're going to do that now. So we'll have to do a bit less soldering and a bit more programming.
Okay, well, when we see them, we'll be guided by, your advice agrees with what we've learned over the years, that apart from soldering the robot, they give it its name. That is a big thing.
Yes, they love giving it a name.
And the name goes on the outside of the box. So this box has just got 1 written on it. I would expect that to be covered with a name once they've named the robot 1. I wouldn't expect them. Yeah, there's a lot of straightforward soldering on the sensor board. That's not quite so personal as doing the robot.
They could
We'll
do
see.
everything apart from the piggyback board.
Okay, we've built 6 out of the 15 that you sent us. So that leaves 9 to construct, which I think is plenty to keep us going for the near future.
Hopefully, we were going to get the teachers to construct 1 or 2 because they've never soldered before. They have no electronic experience.
Max says there's a cupboard full of soldering irons.
Yes, but that's from a previous teacher.
Yes. So, yeah, it depends who we're working with and what they're like. But yes, I agree with you. If it's their robot, then it'll be a better experience for them.
Sorry, we interrupted you as invited, so we'll let you.
I'm glad you did. They would be responsible for the tuning, for line following, and the method of interactive single button tuning, the old TV remote. You probably saw us using them on the pickaxe. But press one button to choose your function, and then plus and minus to rip up and down, and then another button to write it permanently into the appropriate file. So they can tune it, and they can see immediately what happens when they get it wrong, and they can go back a bit from the peak. So it's very much competition style work. And we will be using the stationary line follower technique with the speed set to 0, but the error factor will be progressively more, and it will get stronger and stronger to the middle, and it will start oscillating, and then you bring the D factor in, and it will stop oscillating. So that is one line of learning, and that's the reason why we've gone for the TV remote.
Will you be able to change your numbers while it's actually moving around the course?
Yeah,
Yes.
yeah. I've got a video. I'll see if I can play it to you somehow. Hang on a minute. Let's have a look.
Because I found that incredibly educational.
Yeah.
You could really make it hang out around the corners by fiddling with your KPs and
I'm
PIDs.
trying to think where the video is.
Yeah, it doesn't matter.
Those are.
When they change the values, if they sort of press the button a couple of times, they'll have forgotten what number it's set at. Is there any way they can tell what the settings currently are?
There is. And if I. Let's just see if I can show you. Come here. Right. Yes, they can if they use Bluetooth. Tab. And we can do that one. Share that one. Right. That's what will be on their Bluetooth screen. And they'll be using, for the Bluetooth, that says the buttons they can use. So they can press a button for speed. Oh gosh, what's going on? They can press a button for speed, and then they can press plus. And you can see on the left here, they'll get back, having pressed plus, they'll get back the new speed. And a plus again, and they'll get 70. So if they press 5, it'll go up and down in steps of 5. And if they press 1, it'll go up and down in steps of 1.
Nice.
There's a press of S there for speed, and it reports back what the current speed is. And on this occasion, got switched off. So yes, they won't have to keep notes in their notebook as to what they've set it to, because they'll press the WR button on the Bluetooth, and it will be written to the params.py file, which, when they get it back into Thonny and switch on the view mode file, they can actually read the parameters back on screen through Thonny.
It's rather cool.
Okay. Where are we? Yes. Does that answer your question? Yeah.
Yeah. Looks really interesting. The Bluetooth.
Yes.
What device are they? Is that sort of to the PC?
Well, that's something else to find out when we get to the school.
Oh, right.
I use the good old phone.
Yeah.
But whether they're allowed to switch the phones off in the classroom or whether there are tablets available, I really don't know. The laptops might possibly have Bluetooth. They
did have the last school.
Quite likely to. Yes.
Yeah.
I've had problems in a school trying to run more than 2 or 3 Bluetooth devices. where everything gets swamped with the Wi-Fi signal that they've got.
Right.
As soon as you get more than 2 or 3, trying to control 2 or 3 robots using Bluetooth at the same time, you run into all kinds of trouble.
Okay.
So just be aware of that.
Yeah. I'm hoping that different students will be at different stages doing different things. We'll encourage people to look at, for instance, how far ahead where it is. We've got the line sensor on a pair of wires there, and they can experiment on dragging it right out the front, or changing its height, or bringing it right back into its original position. And we did find this made quite a difference. If you use falling off as an option for slowing the motor down, then if the sensor's way out in front, you get more warning and it works better. So some students will be looking at that. Some students might very well be looking at techniques for getting more volts to the motors, which we have done with Mr. Grabowski's robot. We actually just put a AAA battery in series with the output, and that gave us more volts. I don't think we're doing anything quite so drastic here, but with a regulator there, of course we can put 12-volt battery on, and we would tell them what they are doing, but they would be doing it. So there's lots of what should I say, competition-style tuning once they learn it, and there'll be programming, so it won't all be Bluetooth.
You will probably find that they're very keen to run them at the maximum speed.
I know.
And so if you do put 12 volts on it, I guarantee you'll be blowing some motors up.
Yeah.
Don't mind that.
Well, they could try different motors. I mean, these are 30-to-1 moderate power. We've got a 30-to-1 high power one, but I think we've got some 20-to-1 motors coming, which will be 50% faster. And then there's, of course, bigger wheels.
Tyre materials are probably more interesting than anything else. So you might want to do a whole range of experiments with soft O-rings and things like that. Makes a tremendous difference to the performance you can get.
So are you saying traction?
Yeah, tyres on that, yeah.
Yes, I agree.
Yeah.
I have gone to competitions with a little bottle of petrol and a piece of cotton wool. That works quite very well, actually.
It's just for a few seconds.
Yeah, put the lid back on afterwards. Yeah, I think we finished. Software. I talked about using objects, and I talked about using include files. They're actually import files. I talked about the cruise control. Have you all seen the picture of it drawing a square? No. Okay. Let's have a look. See if I can do that. A tab. We've got that one there. It's on YouTube, so I don't know how it's going to show on this. Where's it gone? Come on. There we go. That page will be there. There is the drawing a square. Let's see if I can make it a bit bigger. I don't think I can. Let's have a look. Right. I had to hold the paper still. Yeah, okay, that's YouTube for you. Right. That's our different methods of calibrating there. And I don't know if you've seen this. That is 3 robots with one single TV remote control. So we could get some, try and get them to get all the robots compatible with each other. So tune them so they all behave the same, so they don't end up with this malarkey that we've got. And we can put on some, what's the word where all the dancers do the same thing together?
Synchronized.
Synchronized swimming or synchronized dancing. Yeah. So, right, we'll go back to, hang on, what's happened? I've lost you. Here we go. Right, we're down to questions now. More questions. Any
Oh,
questions?
that sounds really good. Really impressed with what you've done so far.
Thank you.
It's pretty good stuff. I think one thing you might find challenging in the long run is trying to be competitive against, other designs.
Yeah. Well, as you can see, our objective is to get them interested.
Yeah.
And keep them interested. And hopefully winning competitions isn't necessary for them to be interested.
Yeah.
But yes, it does help to win competitions.
Well, in the modern era, you get a medal for getting around the course.
Yeah.
So if they come home with medals, they've done something,
Yeah. Yeah.
You can also host your own school competition between your students, and those will be all reasonably comparable, and they enjoy doing that as well, especially if you got some prizes, some, bag of chocolates or something or other.
And you will find the ones that have worked hardest on their development are the ones who do best. So it's
Right.
clear that the harder you work, the better you do.
Yeah. One thing I would explore, and that is self-timing robots. The Pico's got very good time measurement, and if they go on the line following course, it can report back through Bluetooth as to how long it took to go round, and they can use that for their own tuning to if something they do gives a better figure, and we can also use it for competitions. But we would need we haven't actually done the stop sensor yet of the sides, but I'm trying to see if we can do that through a digital input rather than an analog input. But we could just have a potentiometer for adjusting it so that it works okay on the white lines. Right. I think I've run out of material. Okay. Well, thank you for your encouraging comments and suggestions.
Thank you, John.
Yeah.
Thanks, Simon. It's good to see it being tweaked and changed around like it is being. And
Yeah.
we've been through this before. I mean, the schools are all into Python, so getting that Pico on there so you can program in Python is always going to carry more weight with the schools, I think.
There's one thing that I think would be helpful if you could ever change it, and that is this 4-pin socket.
Yeah.
To be compatible with the HC06.
Yeah. We've had that one on the to-do list as a sort of next revision, because that came to light pretty much as soon as we built the first one. I went, wouldn't it be good if the HC05 or 6 could plug in here directly?
One problem you get there is you buy different ones and they have different pinouts. They're not all the same.
Okay.
Yeah. We pick one obviously that is okay.
Yeah.
It's like the LCD, not LCD, the OLED, little OLED displays. You buy a dozen of those and they have they're the same pins, but they put different pinouts on them.
Yeah.
So you need to be careful of that.
Well, Bluetooth modules are notorious. I bought 2 at the same time on the basis they'd be the same, and that was a joke. They were completely different when they arrived in the post. But there we go. Thanks ever so much, guys. I think it was really interesting, and I hope you keep us posted on how you get on. Hopefully you're getting to see the teachers at some point.
Well, that website that you've got the address of now,
Yeah.
We may be able to use that at the school, put worksheets on there.
Sure.
It's got a contact us page and they can feed back to us, but whether we'll have such good communication with the students, I don't know. Depends on the school.
Okay.
It would be interesting to find out exactly what the teachers are expecting to get out of this.
Yeah.
I think.
Well,
We'll know after the first lesson.
we'll keep you posted. Have you got access to our Dropbox link? I know you'd probably rather we use something you're using.
You've given me access to your Dropbox, John. I've got it. Yeah.
Yeah. Okay.
So I'm just copying your link away somewhere safe for a minute. So just bear with me while I move around here.
If you want ammunition to sell this to teachers, my robot group here, people who've graduated from my robot group. We've got 2 in Imperial College and a 3rd one studying computer science at Manchester. MicroMouse is a really useful thing to take along to university interviews and things.
Yeah,
Okay.
sure. Yeah, we've had a few.
Yeah.
Right. I guess really we're on to now. Anybody wants to talk about what they've been doing, show and tell type stuff, or anything else you want to discuss? So the floor's open to anybody.
That's a good question. The entrance to this the Hazlemere competition, is that just turn up and play, or do you have to register, or how's it work normally?
You can just turn up, and there will be registration when you're there to register your robot. Put it onto the timing system, so we know when you come and run. So, how's your build coming along, Neil?
Well, I'm just about there with the hardware. I've got I put it all together. I haven't quite got around to calibrating it and trying it out for real yet, but at least it's hardware complete now.
Right.
So just on the basic build as you've got on the website at the moment. So no tweaks really, but yeah, we'll see how it goes.
On the website, there's loads of sample code and the Maze Runner stuff. It takes a little bit of attention, but it runs really well with that stuff in it.
Yeah, well, just one question on that. I pulled down stuff from GitHub and put that on it. But what I wasn't 100% sure whether, because it mentions, is it the Dorothy branch, which I couldn't find. I wasn't quite sure if that was still current or whether it was an old comment.
I think the Dorothy branch has been merged back into the Maze Runner, so all the Dorothy stuff is in that.
Yeah,
Maze Runner code.
That was the impression I got. So all right, so I just need to try that out. I haven't quite. I was waiting for a couple of bits, which I've just got literally today. So I've just got myself a Bluetooth module, so I've just put that on to.
I get a pen on your calendar and pencil some days out just before the competition.
Absolutely.
A few nights as well, maybe.
Yeah.
Okay. Anybody else? Anything?
I'm working on something just to annoy Pete and Rob.
Good.
This is a half-size through-hole solver.
Good.
Right. What are the motors on that, Duncan?
They're those little tiny stepper motors.
Right.
Okay. So is that going to be running?
It's the one I'm working on at the moment.
Hopefully.
It's the same as C15 and SS80, but using reflected light sensors. So it's a classic LEDs business there.
Are you going to publish the design, Duncan, at some point?
You're welcome to the PCBs and so on. I can get PCBs and photographs, circuit diagram, that kind of stuff.
Yeah.
I just thought I'd wind you up,
No, it's fine. More the better, Duncan.
Oh, great.
Don't rely on me and Pete to produce a reference design. If you get there before us, I'm quite happy.
You'll steal it with glee, won't you?
We should have. It'd be great to have a reference stepper.
Yeah. Right. Absolutely, it would.
I like stepper designs.
It makes it easy to do a solver.
Yes.
You haven't got any of the dynamic problems, and you're not writing a complicated PID or anything like that.
What CPU did you put on there, Duncan?
So which?
What micro?
But it's an XMC to go, this thing.
Oh, yeah, I know.
And these are two of the, is it Palulu stepper drivers?
Yeah.
But these are eBay rip-offs of them.
Yeah.
I think I got 5 of them for £7 or something. And I got 10 of the motors for £7 or something.
What do you use for wheels again? Have we seen these wheels before?
Right, these wheels, the wheels is the weak point. These are lasered out of 3mm MDF with an O-ring glued on.
Right.
They're not really good enough. I mean, I'd have to probably make about 10 of them to get 2 I could use.
Right.
So what I'm actually going to do is turn some up on the lathe, which isn't really a very practical solution for general people. But I've got an idea about how to make wheels, which that might be next year's Minos talk.
Right.
Cool.
What size is the shaft on the motor?
1mm.
All right, it's interference fit 1mm, yeah?
So?
Interference fit 1mm, so it's a round shaft.
Yeah. Well, it's more glue than interference, but yeah. I can't drill a 0.95mm hole.
Oh, I don't know.
That's your sense of adventure.
Oh, I don't know. Just can't get the start.
Duncan, there's there you go, a bit of competition for you.
Is that through hole?
Let's say through hole stepper motor, but it's nowhere near as far on as yours, so I don't know if that's ever going to run.
Which stepper motors did you use?
Which
steppers did you use?
I can't remember what they're called. They're just some off of eBay, like you, £7 for a bag of them.
Mm-hmm.
I think they're a little bit bigger than yours by the look of it.
These are about 8mm diameter, I think.
Oh, these are bigger than that, but not a lot bigger. Yeah.
What might be useful, Duncan, would be if you could if you've got sort of references to your source of materials, that would save people quite a lot of time, probably, because that's what you spend a lot of time doing, is rooting around. So if there's any links to your parts, that would be useful.
I think I sent them to Pete last time.
Right.
But yeah, I mean, they'll be in my eBay purchase history.
Yeah, they will, yeah.
We'll find it. Yeah, these are about 16mm
Wow.
tall, these ones. So
you'll be a lot faster than me then.
well, who knows? Or we'll only go 6 inches forward and the battery will run out.
that was the problem on C15.
Yeah, I was wondering about that, because didn't you have like a 2,500 milliampere hour battery on that? And I thought,
I've got one of these bloody great things.
Yeah, what's the capacity on those?
Well, 2,200 milliampere hours.
Yeah, so I mean, I'm hoping to use something like 100. No, never mind 2,000.
This one uses what is it? They are. Can't read it. 350s, I think. They're that sort of size.
Right. Yeah.
Yeah.
Yeah, but the old version used a single cell and a DC to DC converter to drive the steppers.
Yeah.
Right.
And it was taking, I don't know, an amp or an amp and a half out of the battery. And they can't sustain that load. They do about 20 or 30 seconds and it's good night.
Right. So it's the battery internals that are the problem, because that capacity should keep an amp going for a couple of hours, shouldn't it?
Yeah.
But it won't.
Right, yeah. So the capacity dies as soon as you pull that sort of current out of it is the problem.
Yeah.
I should have read the specifications, but I can't find the specifications. They were cheap off eBay.
Yeah.
Exactly. Okay, anybody else want to talk about?
I've been doing a bit of work on the main board. I don't know if I can just show you. Do a window in a minute. All right. Okay. Yeah, that one. Share. Can you see the?
Yep.
You can see that, can you?
Yeah,
Yep.
we can see that.
Okay. So what I've done is I've increased the width and the hole size on all these resistors down here. and move them so that they offset slightly, which means you've got less chance of soldering into the wrong hole and bunging up the wrong hole. I've also increased the pad sizes down here so that it's easier to solder the wires that go on to the sensor board. And I've made a couple of other little tweaks, but I do plan to also make the changes up here to the serial connector to see if I can get those round in the right sequence. So that's basically what I'm doing at the moment on that.
Can you squeeze a level shifter? Sorry, can you squeeze a level shifter in as well, David?
I can try, yeah.
On the on the Arduino transmit, which will be coming out at 5 volts, which the boards don't tend to like very much.
Yeah. Okay, yeah, no, I can have a go at that.
Have you catered for a bigger reverse polarity diode?
Yes, and also I've put a polarized battery connector in there as well, Molex K2, I think it is. So yeah, a few little tweaks happening there.
There was one question I had. I mean, obviously, I've just built it, so it's sort of fresh in my mind. Is I wondered why the connector to the sensor boards, they weren't aligned above each other, so that you could just literally plug the board directly into the main board.
It mainly comes down to, I think, because of the constraints on the size of the board that we can do with the free version of Eagle. We couldn't get the row of connectors far enough forwards to do that. So most of us ended up with a strip of error board in between. I've
sort of made. You see that? I've made to stretch the. I've just managed to stretch wires across to a connector, so I've managed to do it. It's just pulled across, and it seems to work quite well. But it was just a little bit of a stretch.
Okay, and there is a trick on Eagle that can allow you to do that, because Eagle will not allow you to put a component off of the space, but it will allow you to run tracks, and it will allow you to put wires in. So if you just draw them individually as individual wires and put tracks to them, you can extend the usefulness of Eagle.
Right.
If you need to.
I'll have a look at that when I've done the serial stuff. See if I can get that included as well.
Okay.
The question I had was more the mechanics of it. Was an extra hole to actually put a strap around the battery to hold that in place? Might be useful if we can get an extra hole in the board. So you put a
aren't you aware? Tie wrap or something on it.
Yeah, that's right. So you put a tie wrap or something around it.
Aren't you aware that there are actually some holes there?
There's only one hole on one side of the battery, so
there should be two holes between the connector. And there are two sets of two holes alongside the resistors along the edge of the board. And what we always do is put a bent paper clip in there and then just solder it in and then connect between the ends of the paper clip with an elastic band.
Well, what I've done, I've just done a 3D printed of a clip to put clip around it, but there's an option. But it's. I just thought there was a second hole. Yeah, well, I should take that back off again. But I mean, there's the big hole there, and if there was a big hole and another hole on the other side of where the battery would connect. Can you see it? Sorry, you can't see it. Rather than just have the one hole there, you could have another hole down here. Then you could just put a tie wrap around the battery. Just felt a little bit easier.
Okay.
What I was looking at, that was all.
Okay. Did you have problems with the resistors? You said you made the holes bigger.
Yeah, the problem was not so much getting them in when they put the wrong resistors in, trying to get them out again. Desoldering when you have a very tight hole on the lead is is very difficult, and we got students putting the wrong resistors in a few times. So
it's that tight. It's just that I always find that if you're trying to put a thin lead into a big hole, it makes soldering much more difficult. You know, you need it to.
Yeah. Well, I've only made the hole a little bit bigger, but it's just we had real job clearing the holes of the solder.
They must be very tight if you've got that sort of problem.
Yeah.
I can't say I saw that as a problem at all. The only ones I had a problem with were the diode, which the high power diode I had just wouldn't go through the holes.
Yeah, no, it won't. That's right. So we put a bigger hole in that one now, and the.
And the other thing was the power switch I finished up with. Just finished with a little slider power switch. It's got a couple of like lugs on that hold the switch in place.
Yeah.
Which I've had to bend out of position because obviously there's no hole in the board to go through. So again, another couple of holes might be useful, but nothing major really. Okay,
that just depends on which switch you use. I think the ones we used didn't have the lugs, so yeah. That's fine. Okay, useful comment. So thanks.
Yeah. Thanks, David. Thanks for that. We also we have replenished our stock of line follower boards as well. I think we mentioned it last time, but they have come in from China now. So we are you going to run? You're going to need some of those this term, David. I think you might be, aren't you?
Yeah, I think I probably will. I've got main boards, but I'm out of line follower boards. So I could do with some of those. I'll let you know in the next week or two how many I'm likely to need when I find out how many students I've got.
Yeah, ping me a message because I got 20 more made up.
Oh, brilliant. Okay.
But we seem to be shipping through boards quite a bit now. Okay. Anybody else before we sign off?
Question for go on.
I don't know whether I'm calling it from my phone, but I don't know whether you wanted to see some photos of the half size. I've seen Duncan shown his.
Yeah, we do because I've got a couple of questions on that. So let's see a couple of photos.
Let me see if I can. I don't know how this works from a phone. Let's give it a go. Let me have a look. There you go. Right. So this is the model. Some of you have seen it on. Can you see that? Is it sharing?
Yeah,
I can see that.
Okay. So that's the current model, which has got so the red stuff is resin printed. The white stuff is PLA. I found that I effectively printed a very small. I printed it in resin and in PLA, but the sort of board replica sort of warped because of the thickness. But the mounts seem okay. And I wonder whether I've got it a bit closer. So this was a problem that Derek said, well, yeah, obviously, right, on Facebook. Thanks for that, Derek.
Huh?
So this was
I didn't
a
say
link.
that. I just said how to fix it.
I know. I'm joking. So this is the side of the mount, right? So you can see that these on the right-hand side of this, there is the Scale Electric front tyres, right? So this is off eBay. They're mounted onto sort of resin-printed wheel hubs, and these push fit onto a double gear, right? So that means we don't need to print 0.3 mod gears, you see, which is a bit tricky in resin. Then you've got next to this gear, so that's I guess a nylon gear that's come from Dydal in what's it called? A ridiculous €2 each or something. Next to that, you can see an M2 washer. There's an M2. There's a 2mm bar that runs the axle that runs through. What you can't see just through the resin is there's two bearings back to back in the resin. So these are 6mm outside diameter, 2mm inside diameter. I guess they must be 2.5 millimeter thick. So there's two of them back to back. So that mount side on that you can see there is 5mm wide, and then that white thing on the end is just something rubbishy or knocked up that I haven't actually trimmed properly to stop the axle falling off the end. Then this is the problem. So I printed these are actually the version 4 mounts. I printed some of these face down, some of them sort of the other long face down, and you can see the slightly wider section that I was joking with Derek there. That's where it is onto the resin build plate. So if I'd have spotted that before I'd have mounted them, I'd have done the version 5 ones end on or side on. And what happened when I mounted them, they were off, they were tilted, and I couldn't figure out why they were tilted. This I think is I don't even remember what this is. This is the non-tilted version. So you can see here, you can see the black scale electric tyre on the resin, then the gear wheel. Then on this side, I've actually played around with steel washer and 2 nylon washers, and that's a 2mm bar. And you could just through the resin, you could just about see the 2 bearings. Mm-hmm. And then that's the 6mm by 12mm motors. I've got a whole bunch of these pictures. This is me running the wheels round. I was trying to figure out. I don't know whether it was on this one. This is the version 4 mounts. There was the alignment, especially when you've got the wheels further away, is tricky on something so small. But the current version 5 ones work. That's not right. This is so Pete's planning on putting an STM32F411 on. So I've got a black pill that I'm prototyping with. Now, there is some videos on YouTube. Where would that be? That would probably be here. Which of course it's reset my YouTube channel. Right, so if you do a search for Rob's Edge UK, right, there's a video of the version 3 mounts powered up with 2 AA batteries on extremely long axles, because I hadn't cut any down at that point. And then, if we go back, there's a couple of shorts on it running. So this one, this is it running without any load on, and 2 bits of mod wire. So it seems to run fairly quick. And then Pete says, well, you probably need to weight it down a bit. So if I go to this, these are, you can see them better on YouTube, Rob's Edge UK. So this has got a 500 milliamp battery just for weight. It's not connected to anything, and a £1 coin on the top. I forget what the weight is. I think the weight of the mouse is about 15 grams or so. I could actually look it up and not just make it up out of the top of my head. Let me have a look, see if I can find the weights. Anyway, you can see this is slow motion. You can see pulling back because I'm obviously inserting putting a. So you can see it bucking at the beginning of pulling, doing a wheelie right at the start of this in slow motion because I'm obviously applying 3 volts straight onto both motors. Anyway, Pete says he's going to design a board, so there you go.
Okay.
The designs, if anybody wants to look at the code, the designs are on the UKMARS on the UKMARS GitHub page under MicroMouse or something.
Right. That's the code for creating the
it's a plastic, yeah.
It's a plastic, yeah, not the code for running the mouse.
No. It's open. Sorry, I've used free CAD in the past. I know Pete uses Fusion, but I tend to be an OpenSCAD guy because I'm a software engineer really at heart. So OpenSCAD allows me to type code in, and you get 3D models out the back. So,
is that where are you proposing to put the battery? I assume that battery is not.
Yeah, a bit like. That's an interesting question. Have I got? So, have you seen the photo? Pete's photos of Sapphire?
Yeah, I've got photos.
A bit like that.
Right, but if you look at with 2.5 mil things and the wheels sticking out, and then you've got the magnet in the middle, you're not going to have enough room in the middle to stick the battery, which is where Sapphire puts it.
Yeah, it's going to be tricky, I think.
Unless you found a ridiculously small battery.
Yeah, so we'll see. Pete's got to fit all the stuff on the PCB first. So yeah, I don't think I've got
those aren't magnets, are they? They're fake printed things.
Corrected.
You can actually put the magnets on. No. One of the problems I've had with the magnets or with connecting the magnets is they attract to the motor so much that they'll, if you don't put a really strong link between the axle and the magnet, they literally will bend it out or pull it off, and you end up with it rattling, with not balanced. Right. That could be an issue.
Yeah.
That's because they're very strong. Those. How big is the magnet that you're looking at using?
I don't know.
3 or 4 mil.
Yeah.
How big's the one that's on there?
Pete was looking at that, so I don't think we've finalised on it yet.
Right. Okay. That's That's all looking interesting.
I like your resin printing. Which printer is it?
UKMARS. A standard UKMARS. 200 quid.
Same as yours, Derek?
Yeah, that's the same as mine.
It's probably the Derek that told me about it in the first place. I think I had a look at one, so I don't know. That must have been 2 years ago.
Yeah, there's our mount, which is very similar. They're just not quite square.
To be honest, they're brilliant in terms of resolution. They're fantastic. You can almost print 0.5 mod gears. I don't know how the materials stand.
Yeah, I've successfully printed 0.4 mod and used them, but they're not as good as bought ones, but they're usable. But you can't do it by 0.3.
No. So, but the only pain with resin printers, of course, is the resin, because you can't leave it in the bath. They tell you to take it out after 48 hours.
That's odd, because I've left mine in there 6 months and used it, and it's fine.
Maybe.
Yeah.
Right. Okay.
So give it a stir, and it seems to be okay.
Yeah, I mean, if you can avoid taking the resin in and out, then
it helps.
It does help. The resin's not. They give you loads of warnings. They're not even sure what happens when humans get it on their skin.
Oh, I think there's an awful lot of over safety hype, especially on YouTube. I mean, there are people walking in hazmat suits and
I know,
just to cure the thing, which is just ridiculous.
Yeah.
But it's not nice stuff. And if you drop it on your carpet, you're stuffed.
Yeah, I mean, if you UV, you get a solid lump on your carpet. So, I mean, as Derek pointed out, the cure is just to set it right. If you get it on, anything you don't want it on, then set it stops being resin. It's only resin that's a problem.
It's just like dripping glue or something onto things.
Yeah.
How about the smell and so on?
Say that again, sorry.
How about the smell and so on? Are you having to do it outdoors or something?
It's not. Well, I've got mine in the living room. And
I've got mine in the living room, and it's been there for a year. No problem.
I mean, the IPA is almost worse than the resin.
Yes, it is.
When you take the cover off the printer, you get a waft. Obviously, you don't want to do it in a small contained room and what's it called. But Claire said rather than have it down the workshop and never see me, that she could put it in the living room. So it can't be that bad, can it?
It's no worse than doing some glue. Yeah, and you don't get, while it's printing, you don't get anything, just when you're handling afterwards.
Agreed.
Okay, thanks, guys. Anybody else? I'm about to sign off, I think, myself, but if anyone wants to stay on the call and have a chat, then the call will stay open until the last person leaves it. So anyone, any more for any more? Otherwise, I'll say goodnight.
Whatever state the robots are in, I'll bring the sample bits for you to have a look at.
Yep. It'd be nice to see you and to see them against the half-size maze as well.
Yeah, agreed.
Yeah, brilliant. Okay, well, thank you guys. Thanks for joining us, and hopefully see you all at Hazlemere in.
What date is Hazlemere again?
Second.
Second, yeah.
Ah, right, okay.
So three and a half weeks according to Duncan. All right. Okay, guys. Thanks a lot. Good
Thanks,
night.
everyone.
Take care.
Bye.
Cheers.
Bye.
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 Bye.